Okay, so we're transitioning into doing identities for a little bit, and identities, some of it is going to be, I don't know, showing that you understand mathematics. You have to like show the steps, kind of like a proof. Kind of like a proof. I know that makes you like super nervous. You just have to show all your steps. Seth, are you listening? You're not allowed to go from start to finish with no work. That's what these are going to be all about. So, showing steps. So we're going to start with just fundamental ones, reciprocal identities. Reciprocal means flip it. So if I were to flip sine, it would turn into what? Cosecant. So sine u, by the way, the u is just like an x or a theta. It's just another letter. So the reciprocal of sine u is 1 over cosecant u. The reciprocal of cosine u is 1 over sine u. The reciprocal of tangent u is, any guesses? 1 over cotangent u. And the reciprocal of cosecant u is 1 over sine u. Secant is 1 over cosine, and cotangent is 1 over tangent. Those are reciprocal identities. That means if I ever see 1 over sine in a problem, I could, if I wanted to, make it cosecant. They're equal to each other, so I can substitute them. Then I have a little example off to the side that says, let's multiply sine x times cosine x and show that it equals 1. We're going to multiply this together and show it equals 1. There's more than one way to do this, but what I would do is I would see cosecant right there and say, ooh, I'm going to replace that with the reciprocal. So I'll have sine x multiplied by 1 over sine x, which is the reciprocal of cosecant x. And then sine x is over 1. What happens when I multiply those together? What happens when I multiply those together? They cancel out and I get what? So then we just proved that this is true by showing our steps. Okay, next section is quotient identities, and the word quotient means divide. So you should know that tangent is what over what? Y over x. And y is the same thing as sine. And cosine is x. So tangent u is the same thing as sine u over cosine u. Same thing, only this time cotangent. Cotangent is x over y. So cotangent u is the same thing as cosine u over sine u. So those are quotient identities. Or if I see tangent in a problem, I could substitute it with sine u over cosine u if that would help me get to what I want to get to in the problem. The next 4 examples are just kind of some other things that I felt would be helpful to show you. The first one is sine x times sine x. If I were to multiply these together, it would be a squared, right? But it's weird how we write it. We write it like this, sine squared x. And that's because we're not squaring x. X is the angle. We're not actually squaring the angle. We're squaring the sine. We're taking the sine at that angle, and then we're squaring that answer. So we're only squaring the sine of the angle. So if I were to do tangent x times tangent x, what do you think that would be? Tangent squared x. So it's squared tangent at that same angle, x. And there are other ways of writing tangent squared x. I just went over 2 of them. Do you know what I could replace tangent squared x with if I needed to? You don't for this, but I'm saying if you needed to. sine squared x over cosine squared x. So if tangent is squared, so are the sines and the cosines. There's another way of writing it also, using the reciprocal identity. I get this? Reciprocal? It's a reciprocal of tangent. So you could write it that way if you needed to for any reason. So these are all equivalent to each other. And then if I have something like cosine squared x divided by cosine x, well, cosine squared x is the same thing as cosine x times cosine x. And what would happen in this case? Tell me to do it. Cancel them, and we would just get cosine x. So you can reduce those. And then this last one is one that saves me a lot of time. If you can understand it, saves me a lot of time. So you have secant x on the bottom. What's secant x the same as? Same as 1 over cosine, except for secant x is already 1. It's like already on the denominator. This secant x is already 1 over secant x. So that's actually just cosine on the top. So I can rewrite this as cosine squared x, because I moved the secant up. So secant x. I can just move it up and change to whatever the reciprocal is. There's something else I could do if I needed to, and I don't necessarily need to, but I'm going to go over it so you've seen it. What's cosecant x the same as? It's the same as 1 over sine x. And right now, cosecant x is just like not a reciprocal. So if I were to make that into 1 over sine x, that would just take this cosecant x and put it underneath the thing it's already attached to. So I can just rewrite this as cosine squared x over sine x. So I'm just like, when you move it to the top or the bottom, you change what it is. It only works if it's like multiplied or divided by that thing, by the other stuff. It doesn't work over addition. All right, and then there's 9 more identities. There's 9 of them that we're going to go through. And I'm going to show you how you get them. You don't have to go through the same process. We're doing it one time, so you've seen it, and then from there you can just use them. Just so you know how they are made, we'll do it the one time. So the very first one is going to be sine squared u plus cosine squared u equals 1. That's number 1. There's 9 of them. That's number 1. And this one comes from, what's sine? Sine is y. And cosine is x. And it comes from the Pythagorean theorem saying if I take a squared plus b squared has to equal c squared. So my x and my y squared added together has to equal the radius squared, where the radius is 1 in a unit circle. So that's where that identity comes from. And it works. If you were to do like 30 degrees and you square the sine at 30 degrees and you square the cosine at 30 degrees, you add them up, you get 1. So it works every time. So that's the first identity. Now we're going to manipulate that, just using math that we've learned throughout our years as mathematics students. I'm going to start with subtraction. Okay? I'm going to take this equation and I'm just going to subtract cosine squared from both sides. So if I subtract cosine squared u from both sides, I now have sine squared u equals 1 minus cosine squared u. There is my second Pythagorean identity. See how easy that was to manipulate it and change it into something else. Now this is telling me what sine squared always equals. So if you ever had in one of these problems 1 minus cosine squared u, you could take it out and replace it with sine squared u, which is easier than 1 minus cosine squared u. I'm going to get a third one the same way. I'm going to go back up to that same original, and I'm going to subtract sine squared u this time. If I subtract sine squared u from both sides, now I have cosine squared u equals 1 minus sine squared u. Now I have 3 Pythagorean identities. How many are we going for? 9. So as you are putting your work in there, like if you want to highlight or circle or something, the final 9, that would be good. That way you can just refer to it quickly. You see in the middle how it says like divide both sides by, I forget which one's first, I think it's sine. Does it say sine squared? Yeah. So I'm going to change my page, but you're just basically moving to the middle of the paper now. And I would write this down, so you can write down how we're dividing by sine squared u. But I would write down sine squared u plus cosine squared u equals 1 again, and then this is an equal sign, so as long as I do the same thing to both sides, I can do whatever I want. So if I want to divide both sides by sine squared u, as long as I do to everything I can. And now we're going to get our next one. You notice that?
Is that going to be?
What's sine squared u over sine squared u?
That is
No, nothing. 1
plus
cotangent squared u.
equals,
Yes. So that is number 4 for our new identities. That's the 4th one. And all we did was divide everything by sine squared u, which we're allowed to do because it's an equal sign. And you won't have to do this every single time. You'll just have this to look at every single time. It just means so much better. It means so much more when you figure it out of yourself, right? Okay. So now I'm going to use addition or subtraction. I think I'm using subtraction to just rearrange these and get 2 more from this one. So subtract 1 from both sides, and I'll have what cotangent squared equals. I subtracted 1 from both sides. Or up here, if I subtracted cotangent u squared from both sides. So that's 7, 8, and 9 right there. Or no, it's not. It's 5, 6, 4, 5, 6. Remember, you're allowed to do anything you want as long as you do it to both sides. If you wanted to, for any reason, have it equal -1, what would you have to do to this side? I would have cotangent squared u minus cosecant squared u equals -1. So you could even rearrange them more. That's not one of my 9, but you could make more than 9. Okay, so this would be something that could come up at some point. You just have to see that all the signs are switched. Okay, last one before lunch is now we're going to divide everything by cosine squared u, right? The 3rd column. So we're going to write sine squared u plus cosine squared u equals 1, then divide everything by cosine squared u. And sine squared u divided by cosine squared u is tangent squared u plus cosine over cosine 1 equals 1 over cosine secant squared u. So I'll get my number 7. And then to get 8 and 9, we're just going to subtract things to solve it for different pieces. So I'll subtract 1 from both sides, and I'll get tangent squared u equals secant squared u minus 1. Or I'd subtract 1 from both sides, and I would get secant squared u minus, oh, I said the wrong thing. Subtract tangent squared u from both sides. And I get it equal to 1. And then if you feel like I went too fast through those, of course there will be a video posted, and the notes will be on Canvas and also on my notes. I've typed them all up too, so you can not have to worry about reading my own handwriting, you can retype. So there are a few examples we'll just do quickly after lunch, but I'm going to stop the video and just make a new one after lunch, and I'll stop typing for now.